I'm Dr. Lizzie Sagoo, President-elect of the British Society of Soil Science, and I'm delighted to welcome you all to our third webinar of the year. So before I welcome our presenters, I'd just like to introduce the British Society of Soil Science as hosts of today's webinar. We're an established membership organisation and charity committed to the study of soil in its widest aspects. We bring together those working within academia and have a growing membership amongst practitioners implementing soil science in industry and those with a keen interest in soils. So we plan to host 10 webinars this year, so keep an eye out on our website for further details. Before we begin, just some basic housekeeping. All your microphones have been muted. We'll be answering questions at the end of the presentation, and we'll be monitoring these throughout the webinar. So if you have any questions, please submit these in the question box a few minutes before the end to allow us to get through them. So today's presentation has also been awarded BASIS and Rosso points. So if you're registered with either of these bodies, please contact us directly after the event. And finally, please be aware that we're recording today's presentations. So I'd like to introduce you to our presenters today, who are from the University of Sydney. So we've got Dr. Sandra Evangelista and Dr. Julio Pachon. And apologies because we haven't managed to get Alex. We're meant to also have Professor Alex McBratney on, and we're really sorry to Alex that we were unable to get him on today, but pleased that Sandra and Julio have been happy to stay on. So Sandra holds a Bachelor of Science in Agriculture and a PhD in Soil Science, both from the University of Sydney. Her research focuses on developing quantitative frameworks to quantify soil security. She also collaborates closely with researchers in India on the development of an AI-based monitoring platform for soil carbon sequestration. Julio Pachon holds a PhD from the University of Florida and is a soil scientist at the University of Sydney. He's passionate about conservation and improved land management. His work spans soil security, pedometrics, hydrology, drawing on research and field experience across national parks, mangroves, forest systems, and agricultural regions in Brazil, Ecuador, Tanzania, Australia, and the United States to understand their interconnections and improve monitoring of land, water, and mineral resources. So over to you, Sandra. Are you able to share your screen?
Yes, before Sandra goes ahead, we wanted to read a statement by Alex, if that's okay.
Perfect, thank you.
Yeah, so welcome everyone. Apologies that we were having some technical difficulties with Alex right before, but I want to read out his statement. It is on the first person, so and you're not gonna hear the Scottish accent, you're not seeing Alex at the moment, but bear with me. I will try to modify it as I read it along to make sure that it goes in third person. But it is a great pleasure to be speaking once again with colleagues and compatriots in Britain. Alex would like to thank the British Society of Soil Science for facilitating this webinar. Back in 2012, while teaching undergraduate courses on soil quality and soil health, Alex found himself repeatedly presenting these concepts without feeling that he fully understood them. Despite teaching the material several times, he struggled to find a clear and adequate definition for either soil quality or soil health. That prompted him to step back and think more deeply about how those ideas might be defined and quantified in a more systematic manner. As a result, a year or so later, Alex developed and taught the concept of soil security. He was drawn to the term because it aligns naturally to the related ideas such as food security and water security. In his mind, soil security represents an existential challenge, comparable in importance to climate change, biodiversity protection, food security, water security, and human health. Since then, Alex and his group has been steadily developing the concept into a formal assessment framework. The soil security concept is structured around 5 dimensions. First, it recognizes that soil in its natural state is not inherently unhealthy. Rather, soils have different capacities to perform functions, deliver services, and respond to threats. We therefore define capacity as the inherent ability of soil to perform these roles. Human activity can modify this inherent capacity, leading to changes in the soil's condition, the second dimension, a concept closely aligned with what is often referred to as soil health. Condition, or soil health, is assessed by comparing soil under stress with the same soil under lower stress or more natural conditions. This comparison can be operationalized under the concepts of genosoil and phenosoil. Beyond capacity and condition, soil security also recognizes that capital, the value of soil, encompassing both the productive value and its role in natural capital. In addition, soil is more secure when people understand it, value it, and engage with it. This relationship between people and soil is captured by the dimension of connectivity. A soil may be in excellent condition, yet if no one is aware of its responsible or is responsible for its stewardship, it may still be considered insecure. Finally, soil security acknowledges the need for appropriate governance, laws, policies, and institutions play a critical role in how soils are treated and protected, giving rise to the dimension of codification. While attending the Eurosoil in Seville last year, Alex listened to many presentations on soil health, and he was struck by the fact that there were almost as many interpretations and approaches to soil health as there were talks. While much of the attention was given to indicators, there was relatively little discussion of underlying concepts. In this sense, the situation remains much as it was back in 2012, vague and perhaps more confusing, perhaps even more confusing. Soil security is intended to address this gap. Taken together, soil security is an overarching concept that seeks to safeguard soils into the future. And today, my colleagues here at the University of Sydney, Sandra Evangelista, and me, Julio Pachon, will discuss in more detail how soil security can be assessed and how the concept can be applied in practice. You will also hear briefly about Aurora, or Soil Security Think Tank, which focuses on soil policy as well as soil science. With that, Alex, thanks you again. And yeah, we can move on to Sandra.
Thank you, everyone, for your patience. And I'm very delighted for this opportunity to share with you the Soil Security Assessment Framework and particularly take you through these two dimensions that Julio mentioned, capacity and condition. Now, there are various soil care concepts out there, and you might have heard of some of these, like soil quality, soil health, soil fertility, soil protection, and more recently, hopefully some of you would have heard of soil security. Soil security is a higher level concept. It's overarching, like an umbrella, that includes all of these other soil care concepts. The definition or soil security defined is that it's the responsible management, preservation, and restoration of soil to guarantee its continued ability to perform vital functions, provide essential planetary services, and protect against emerging threats to support life on Earth. We all know and heard about food security, water security, and energy security. And this idea of security is framing an issue as an existential threat to a population. So when we use the term security, soil security, it is in the same essence. Soil, like food, like water and energy, is essential for our survival. Now, soil is special because it is linked to these other challenges that we face today. But when the soil is secured, it can offer some of the solutions to these other challenges. However, achieving soil security is a global existential challenge in itself. Now, in soil security, we recognize that there are different roles of the soil. Soil functions, but it also provides services which are linked to the existential challenges, and also has a potential to, or an ability, natural ability to, or resilience against against threats. As Julio mentioned, soil security also recognizes 5 different dimensions that are needed for soil to be secure. 2 that are biophysical, and 3 that address socio-economic and governance aspects of the soil. In this presentation, I will focus on capacity and condition, and you'll get to hear more about these socio-economic dimensions from Julio a bit later. So capacity reflects the inherent ability of soil to perform a certain role. You can think about it as its natural potential of the soil. And this is what some may call soil quality, whereas condition reflects the current state of the soil and how it's currently performing. As Julio mentioned, condition is closely aligned to what is referred to as soil health. And the reason we have this capacity dimension is because the philosophy of soil security is deeply rooted in pedodiversity. And pedodiversity is the heterogeneity or diversity of the soil. Because of the soil forming factors, we get lots of different types of soil, which means the capacity of one soil can differ from another. And this difference in capacity means that we can't expect different soil to function the same way. Now, for the condition dimension, it can only be interpreted when we understand the soil capacity. So we can think of soil capacity or consider it to be the reference or baseline where it remains unchanged over our lifetime. However, condition changes with increasing land use change or how the soil is managed. And to understand how the soil has changed, whether it has improved in condition or degraded, we need to compare it to its capacity, which acts as a reference. So differentiating between soil capacity and condition is one of the many things that makes soil security unique. Capacity gives us an idea of a reference, which we can then compare and interpret the soil condition so that we can better understand how we are affecting the soil. Now onto how we actually measure soil security. Considering that there are 5 dimensions and 23 subcategories of roles, there are 115 possible evaluations. And through this matrix of assessments, the soil security assessment framework provides a systematic way that we can evaluate the soil. And you can do whole evaluations, or you can focus on certain roles and dimensions depending on your needs or the nature of the investigation. To better articulate how the framework can be used in practice, I did a case study during my PhD, which looked at the biophysical aspects, capacity and condition, for one of the soil functions, nutrient cycling. So the assessment framework itself consists of various phases. First is the assessment target, identifying what are we assessing. This is, for my study, the function was nutrient cycling, and the dimensions was capacity and condition for the top soil, the 0 to 10 centimeters. Next was the reference soil selection. So identifying reference soil for capacity and condition. Now, there are various ways or concepts that can be used for reference soils. It would probably be ideal if we had periodic data from 50 to 100 years ago to get this time series comparison, but it's very unlikely that data is available. So we often use the pedogenome concept to find our reference soil. Pedogenons is a type of soil classification that groups soil under similar forming factors. And for each single pedogenon class, you can find two forms. The genosoil, which is the least disturbed soil or form, and the phenosoil, which has been modified by human impact. And this way, it is a space for time substitution. And the genosoil can represent the capacity, and the phenosoil can represent the condition, which we can compare to understand soil change. My case study was in the Hunter Valley wine growing region, which is a few hours north of Sydney. I used the 5 dominant pedogenons identified by Huang in 2018. And for each pedogenon, I sampled both the genosoil and phenosoil. So the genosoil were often soil under remnant vegetation, and the phenosoils were soil under vineyards. Next is the indicator selection, and we select indicators that are relevant to the supply, storage, and transformation of nutrients, which I will show you in a bit later, and the utility estimation. So the utility is, or it indicates the relationship between an indicator and how useful it is to fulfill a specific function, service, or to mitigate a threat. And it transforms indicator values into a unitless score through what we call utility graphs, or more commonly known as scoring functions. They display the overall trend of the relationship on a scale of 0 to 1, 1 being highest utility. So the indicators that were used in my study for supply, it was represented by pH and remaining nutrient supply. For nutrient storage was CEC and organic carbon. For nutrient transformation, it was decomposition rate and respiration rate. And for each one, we devised a utility graph based on expert knowledge on those type of soil. And the final step is to aggregate each of the utility. So there are different ways you can aggregate them, but I used a PCA, or principal component analysis, on the utility of each of the indicators. And from this, I could obtain weights, which were used to calculate the final capacity score. On to the results. Immediately, we could see for each pedogenon, the capacity for the soil to cycle nutrients varied. So this already reflects this pedodiversity. So pedogenons naturally differ in the ability to cycle nutrients. And this is important to know because for management, so we don't exceed the capacity to and potentially degrade the soil, but it also could be important for restoration because from this we have a target to restore it to. Now, when we estimate condition, there can be two ways. You can take the absolute difference or the relative difference, which is a simple division of the phenosoil and genosoil. So to comparing them, and this indicates where there is no change or whether the soil has been improved or degraded. So for each pedogenon, comparing the genosoil and the phenosoil, we can see that for some pedogenons, the condition to cycle nutrients degraded, but for some had actually potentially improved. So using this method, we can identify and prioritize areas that have been degraded. And but this also means that because this area had been a vineyard and managed in a way for over 100 years, pedogenomes that exhibited or went through this similar management practice could respond differently. So the main takeaways of this is that soil security recognizes pedodiversity from capacity and condition, and knowing this capacity can help us to interpret soil condition better. Soil can't be expected to function the same way, and we need to manage the soil within the capacity so that we avoid overexploiting or degrading. But capacity also shows us a target for soil remediation, and those soils that naturally have low capacity are not considered unhealthy, and they have their own purpose in the environment, and these soils are still worth protecting. I'd just like to acknowledge our team here at the University of Sydney and the Australian Research Council for their support of this research. And as Julio mentioned earlier, we have a soil security think tank, and we invite everyone to join as a friend of soil security to learn a bit more about the codification side of things, which Julio will present on shortly. And if for those who are interested to hearing more on soil security, there is a soil security symposium at the World Congress of Soil Science in Nanjing this year. And next year in June 2027, there is the 6th Global Soil Security Conference in Spain. And with that, I thank you very much.
All right, can everyone hear me?
Yes, we can hear you.
So let me go ahead and share my screen. Okay, thank you, Sandra. And like she said, I will be talking about the capital connectivity and codification dimensions of soil security. But let me tell you where I'm coming from to you. I'm in Narrabri, which is about 415 kilometers away from Sydney. There is a research station out here at the International Center of Crop and Digital Agriculture. And off of Mount Capitar, we get a lot of volcanic material that makes this area rich in volcanic soils, invertic soils. So this is where I'm coming to you from, and this is the land of the Galimoroi people. Just a couple of pictures from drones, so you can see what we have out here. The yellow is some canola. We also have some wheat. And on the right, you can see a drone image captured by Amanda Graff about a project that is being led by Tom O'Donoghue that looks at the impact that cover crops have on the condition of soil. Now, again, soil security is about responsible management, preservation, and restoration of soil to guarantee the ability to perform vital functions, provide essential planetary services, and protect against emerging threats. And just like Sandra said, we have 5 different dimensions, 2 of which are about the biophysical and chemical, more traditional soil sciences that we are accustomed to, while there are 3 that deal more with the socioeconomic and governance component of it. And what we do is that we look at those 5 dimensions across 23 different roles that we separate into services, functions, and threats to soil. And we list the 23 different roles that we think need to be looked at in order to holistically look at soil. So in the end, what we come up with is 115 different evaluations that we need to do, of which Sandra has been able to show you 2 of them. Going back to what Alex was saying, many times when we, to start a presentation about soil, we have to define where are we. And there's this you're saying is a word cloud from 16 different types of, from 16 different definitions of soil health. So as you can see, depending on who you are and what you're working on, you have to spend time being able to declare what is it that you are working on and why. Instead, we can rapidly communicate where we are in this soil security by using this scheme where, again, we have the dimensions on the top and they're the columns, and we look at the different roles as in them. So for example, Sandra was able to look at the storing and regulator of nutrients and their capacity and condition. But these are the things that are missing. When you're monitoring soils, we need to make sure that we have this information available to soil scientists, because one of the biggest drivers, or the biggest driver in many soils, is anthropogenic. And we need to understand how we value soils impacts that management, the connectivity and how that impacts that management, and then also the laws that drive that management. Now, usually you go capital, connectivity, and codification. I want to start with connectivity because those who know learn to care, and those who care will lobby. And I want to run through a quick exercise with you guys. I want you to just think of soil that you know, that you depend on. Maybe if you know where your food comes from, what kind of soil does it come from? If you have, where does your water get purified in the hydrological unit that you live in? So can you think of that soil? And can you tell me, and can you think of where it is very specifically? Give you just a second for that. In connectivity, we came up with this framework here that mirrors the work done by Emma Leonard. And the idea is to try to understand knowledge, action, and attitude. How much do you know about particular soil? How do you interact with that particular soil? And how much do you think or care about the impacts that your actions have in that soil? And the way that we did, so we had a project that allowed us to look at 8 different roles. And again, one of the big efficiencies of soil security is that I can very easily map and tell you what is it that we did and how complete are we getting at this assessment. And so what we did is that we created an evaluation tool. And in that tool, we asked the same question I just asked you. Can you think of a particular soil and can you describe it? Can you give us the coordinates so that we can then use those coordinates to unify it to the other dimensions, so we can understand based on the other maps and models, the capacity, the condition, the codification. To recreate that evaluation tool, there is a GitHub, and you can get that code available in that QR code. And this is the example of the questions that we asked for that. So for knowledge, we asked different levels of difficulty of questions, and in this particular case was about decarbonization. So how many of these did you know beforehand? And then one of the things to think about is, what does the utility graph that Sandra was talking about look like for something like this? The other question was about the action. So how do you interact it? Again, this is about the questions that we asked about decarbonization. So think of this one for a second on the soil that you thought about. And then for the attitude, we asked on the opinions that they had. We finally created a utility out of those and combined them into a single utility graph so that we can have a unique score of the level of connectivity that people had, not only with decarbonization, but again, over the 8 different soil roles. And this is one of the results. So again, I asked you about carbonization, and across Australia, what you could see is that there's a high level of knowledge, and then attitude was probably the weakest around different areas, and action was somewhere in between. And that tells us that there's a little bit of a no-do gap there, and there are opportunities to promote and incentivize social security. Because the density of population in Australia is so low, it makes it a little bit harder to get a very high resolution map. But nonetheless, for this study, we were able to map it in this way. If you want more information, you can go to the paper. For the capital, we're trying to understand the economic value of soil, and this paper placed it pretty nicely, I think. So it's about giving a tangible value that could raise public awareness, improve management, and strengthen conservation. So this is not about creating companies that can value you and sell you things. It's about trying to understand the value that we give it as a society. Because many times if we don't think of it in a monetary value, we don't understand, well, what to do with it. And so there are different use values, indirect use values, and non-use values. Use values are what you would think of as fertility for crops, physical support for infrastructure. Indirect use values are more like infiltration capacity, carbon storage, archaeological record. Non-use values is when you preserve it for the future or when there's an intrinsic importance to it. I will be telling you about work done by Nicolas Francos, Alex McBratney, Damien Field, and Budi Minasni on mapping the available water capacity as capital. And so again, you need to find a utility curve and be able to map out how does the value of land change with the available water capacity. And that allowed them to create a map that showed the capital value of that available water holding capacity. And they found out that for about every 1 millimeter of increase in available water capacity, there was a gain in about 293 Australian dollars per hectare in price. Codification is about the policies and laws that protect soil. So it includes regulations, guidelines, legislation, and anything else that we use as society and groups to write down and codify how is it that we're going to be looking at soils, managing soils, protecting soils. And here are some different types of codifications that exist around soil. And Fowlix put together a lot of information about this and about the number of laws per country that there are. And you can see that there is an increase in laws, but only looking at the number of laws is not enough, because based upon the different jurisdictions and many other things, you have many laws that are not necessarily protecting soil or good soil security laws. But currently there is no global soil policy. There is no global instrument such as what we have for biodiversity or for climate change. And that is one of the things that we're trying to change with Aurora. If you just look at the keywords on the legislation in the Fowlix, you can see that there is an asymmetry in the type of legislation that exists out there. I created a very rudimentary dashboard for this. So on the bottom left, you can go ahead and scan that and be able to, and it'll take you to a dashboard where you can explore that data set a little bit better. But we were pretty ambitious out here. We were trying to see for Australia, all of Australia, how well it did across all of the 23 roles. And that meant that we need to look at over 3,733 documents out there that are separated in different jurisdictions, and there are different kinds of legislation as well, from court cases to primary and secondary legislation. And again, it's not really only about whether it exists or not. It's about whether the legislation or the codification actually enhances or protects the soil role, or whether it actually protects it from the soil threat. And the quality of that law, whether there are measurements, whether there's monitoring, whether thresholds. There are so many different ways to go about this, and that we've looked at. Also, there's a utility score, in which in this case looks more like a step ladder, because we're getting to different points of that legislation to understand how it goes. I don't have enough time to show you the preliminary results, but I invite you to join us in Nanjing, where you will be able to see the results from this work, legislation in Australia working for soil security. And but I do want to give you a quick teaser. We were able to bring upon leveling all of these new tools that there are with large language models, being able to really scan through the most promising legislation. And this is one that was able to that I want to show you, in which the Groundwater Control Act is very much about reducing salinization in South Australia, and has very specific types of hydrological models that they wanted them to use. There's different thresholds, there's different monitoring, and therefore we were able to give it a utility score of 1. But if you want to find out more about how we did that, we will shortly be publishing a paper, and we will also be presenting this in Nanjing. With that said, soil security provides foundational solutions to the world's existential challenges, of which we think that soil security itself is an existential challenge that we have to all grapple with. Again, our data sets for monitoring soil are missing the anthropogenic component to them, and we are not going to be able to understand the condition or why the condition of our soils are if we do not bring in these other dimensions in. So my talk is very much about, please start bringing this together on the same data set, start looking at it all together. And with that, I want to thank again the team that we have, the wonderful team that we have at Sydney, along with all the different collaborators across time that made this possible before I got here, and also people from other organizations that we've collaborated with and made this work really well. Again, we invite you to join Aurora, which is the soil security think tank, as a friend of soil security, and we're working towards getting the codification component not only assessed, but also improved. And this is my email at the bottom, julio.pachon@sydney.edu.au. And we hope to see you not in Nanjing, then in Cordoba, Spain, on June 15th to the 18th of 2027. All right, thank you very much.
That's great. That was fascinating. Thank you very much, Sandra, Julio, and Alex, for those great presentations. We've now come to the Q&A part of the webinar. So if anyone's got any questions, please do put them in the chat. We've got a few through already. Sandra's done a great job of answering them in the chat, but I think we had some really good questions there. So I'm going to ask them, ask them live as well, so other people can hear your answers. So we've had a question: what's the best solution to protect soils in the face of climate change? Who wants to take that? Sandra, whether you want to pick that up?
Sure, I can just share my response, and then Julio, if you wanted to add anything, you can definitely do that. So to my mind, I was thinking that it would be, it's a great question, and I was thinking it would be focusing more on what is the most limiting dimension. So for example, soil in an area that has low carbon storage condition to what it is capable of doing, that could be potentially seen as a priority. So then you would change management and try to bring the condition back to its soil carbon storage or sequestration ability or capacity. Or it could be that perhaps soil in a specific area is not well protected, and so governance structures might be needed as a priority. So I guess what I'm trying to say is this soil security assessment framework is useful to help us identify the dimensions that need strengthening so that we can manage it in an effective way. Julio, if you wanted to add anything.
No, I think that it really goes along those ways. I mean, this is the reason why Social Security was developed, because it's about providing that answer. First of all, you gotta recognize the inherent differences of soil. So the best solution starts with understanding your soil and the difference that it has in this capacity to address climate change. The other thing that people don't realize is that we've actually lost a lot of carbon from soils for the last thousands of years because of land management and misuse. We've lost a lot of carbon, meaning that there's a lot of condition that can be improved. If we change the management, there is a huge gap between the capacity and the condition at the moment. So the best solution again is understanding soils are different, really getting at this role to understand the capacity, the condition, understanding how much are we valuing it at the moment, understanding the level of knowledge, action, and attitude people have to it, and making sure that we have the laws that will actually acknowledge the differences in soil and address those properly. So it's really going through the Social Security framework to address this altogether.
Can you hear me?
We can do,
Yes.
Alex. Fantastic to hear you.
That's great.
I'm on my iPhone, so seems to work on the iPhone. Okay, I mean, this is a tough question. I think it's a really good question. I think it's an issue about resilience. So one of the things we do in this soil security framework is to have this concept of genosoils and phenosoils, those soils which have been relatively unaltered by humanity and those ones which have. And of course, because we understand that there are really genosoils out there, we would very carefully be monitoring these genosoils under climate change to see which ones are particularly resilient. In other words, the ones that are not changing very much through climate change, and they become very important for soil security. And obviously, we're looking at the phenosoils to see how different they are from the genosoils. So I think the framework, the ideas, give us some insight in what to look for under climate change. And we do have a project at the moment modeling how genosoils and phenosoils, how we expect them to change under climate change, and to discover which ones indeed are more or less resilient. And so the ones that perhaps have the highest capacity now may not in the future, and the order may change around a little bit. But the question was better than the answer. Thank you very much.
Thanks. Thank you for your answer to that question. Another one we've got, someone's asked about what's the major driving force of nutrient cycling in soils?
I think that was a question for me. So from my study, I found that for these particular soils, and this can be different for different soils, the main driving factors was the CEC, the cation exchange capacity, the organic carbon, and the respiration rate. So, but yeah, you would have to do this assessment for your particular soil to find the particular drivers for that unique soil. Thanks for the question.
We've got a great question here. I don't know whether you want to comment on this. What's the role of youths in soil security?
Sorry, can you repeat that? What's the role of?
Role of youth, so young people. So the younger generation, the role the younger generation would play in soil security.
You know, I've traveled around the world. I've done a lot of different things, and the number one thing that I try to do anywhere I go is to understand my surrounding areas. Now, I love nature and I like hiking and I like doing all these things. Soil is this central sphere among all the other sphere, hydrosphere, lithosphere, atmosphere, even anthroposphere, that allows me to see the world through this filter. So that's I think the number one thing starts with the youth learning about their environment, learning about the soils that are around them, learn to appreciate them, walk over it as much as you can, open a hole, dig through it, understand it, learn a little bit about this jargon that we've developed on horizons and what illuviation and all these different things, because it's really cool. I mean, when you open a hole, when you can see underneath, it's like ripping out a page of a book and reading it and then trying to understand what the book is about. So it's really fascinating, and for the youth, it all starts with learn a little bit of where you are, learn a little bit of that landscape that you depend on, that soil that feeds you, that purifies your water, that cleans your air. Learn a little about it.
I love that answer. Thank you. We've got another
Can
question.
I have a go?
Oh, go for it, Alex. Yeah.
No. Yeah, I mean, I don't claim youth, of course. But of course, I think the question is, what's the role of youth, not in soil, but in soil security, which I think is a slightly tougher question. So my experience of trying to develop this concept is that most of the work is done by the youth. They are the ones who understand this concept readily and can make it grow very fast. So I think the role of youth in soil security is enormous, because they are the ones who will finish the development of this and make it operational, and will create the policies, the science and the policy and the regulations that will change soil, the role of soil and the understanding of soil by the whole of the population. So I think the role of youth is essential in all of this. Thanks.
Thank you. Okay, another question here. At what scale is soil security concept best applied? Did one of you want to comment on sort of the scale issue?
Okay.
Alex,
Alex,
I think
you want to go?
Sorry, I didn't hear the question. No.
So the question was, at what scale is the soil security concept best applied?
At all scales?
All scales.
Because it's based on these ideas. So it applies at all scales. Because we're working on scales from within field soil management, like you would use in precision agriculture. The phenosoils are important in that context. To national scales, because from all of this, and land and catchment scales. So I would say from field scale, catchment scale, national scales, and they cascade upwards, I would say, to build the national kind of actions and policies that might be needed. But we would see soil security assessment being done on farms, catchments, on regions, and nationally. So all scales.
Thank you. A question here, has the framework been tested in radically different climates than those found in Australia? So has it been used elsewhere in sort of quite different climatic conditions?
Can I remind my British colleagues that Australia has radically different climates within it. From Tasmania to the north of Queensland, you go from very temperate climates, and there are alpine climates to tropical climates. So in that sense, it's been tried in different climates. I'll leave it to Sandra. Julio knows more about climate than I do.
Like Alex said, indeed, it's been tested across not only different climates, but also different different paramaterials and different situationships because of the scale that Australia has. So on the natural sense, it's been tested that far. On the scale of the more socioeconomic ones, we have a collaborator in France who's expanded the connectivity and looked at, well, how do the legislation stakeholders there connect to soil? And we also have a collaborator in Spain that is doing all this pedogen mapping and doing all of this work in Spain. And in Mexico, there's been work on understanding the connectivity of the different peoples there. So it is a framework that has worked for many different people in the research, because again, it avoids having to always have to reframe what is soil quality, what is soil health, what is soil fertility. It more closely just lets you see where are we that we're talking about and what is missing at the end of that exercise and what we need to look at and what we need to focus on as well. So good question.
Yeah, we did do a study where we looked at the capacity and condition for a whole range of countries from Chile to the United States. That whole area of the Americas, from as far south as Chile and Argentina, up through the whole continent, up through to Mexico and into some of the United States. So there's a fair range of climate there as well. So yes, we don't see climate as an issue, and we have produced a global map of our pedogenome. So we expect this to apply anywhere or everywhere.
Thank you. Yeah, we've got a few more questions coming in. This is a great question. It might be a tricky one to answer. In your opinion, which of these soil threats is the hardest to manage or reverse once it occurs? Why? So, Alex, did you want to try that question? I don't know whether any of you have got an opinion on. It's a challenging one to answer, isn't it?
If I had a pure choice, I'd say no. But I probably think it's a very tough question, but I think contamination is soil contamination, which is a threat to soil, is very difficult to. I still think we have a very poor idea of the extent of contamination. I think it's more widespread than we imagine, and once soils are contaminated, their remediation is extraordinarily difficult. So I think that contamination is really one, and there are all kinds of herbicides, pesticides, heavy metals. We're talking about microplastics. It's all contamination, and I really do think that's a big challenge.
Yeah. Okay, I think we started a little bit late, so I want to make sure we give you time to answer the questions. So we'll just take two more questions. They're great questions. They're challenging ones to answer though. So we've got one here on how can carbon markets be best shaped to promote soil security? So I don't know whether you've thought in your work about the role of carbon markets, whether there is a role for these markets to support soil security.
We work on carbon market. We work on Australian carbon credit units and how to measure them. So one of the problems we have currently, I would say, in the way we do carbon here in Australia is most of the carbon work is done on pastoral lands, on grasslands, and not on arable land. And it's pretty clear from our soil security work, the biggest deficits in carbon, where the phenosoils and the genosoils are more different, is where we've got continuous arable cultivation. Well, we don't use cultivation, but minimum till, but still we're growing crops continuously. So I've argued with the government, and we are still going through this, that this is the best opportunity for sequestering carbon in carbon markets is to change our focus to the arable lands. In order to do that, we will need to change our crediting system, using a crediting system which we call time-weighted accounting, which takes into account how long the half-lives of the carbon pools that are in the soil. But if you do that and you don't put periods where you can't change practices, then you can bring all of arable into the carbon farming schemes and the crediting schemes that which we have. And if you do that, you will improve your carbon levels, you will improve your soil, and we will make the soil more secure. So I think it all joins up very nicely indeed.
Thank you. So the final question I'm going to ask you, we've had a question from someone joining us from Bangladesh who said to ensure food security, we grow 3 crops per year. And the question is, how can we ensure soil security as well as ensure soil food security? So does anyone want to take that one?
I mean, is the question solely for Bangladesh, or is it at a global
I think it's
component?
probably more at a global level. It's that challenge, isn't it, of where we've got high populations and we need to maximise food production, but this with care for the soil at the same time.
Yeah, I will say this: when I came into soil science, the question was always, oh, how are we going to feed everyone? It was, oh, how are we going to feed this many people? Though the question is not really there anymore, in the sense that we grow more calories than we need, and a lot of the problems that we have in food supply chain is that the calories don't get to the people that need it. And now we're also shifted a lot more to, is the quality of the food good? And now the shift is also to, are we depleting our soils, and how many seasons do we have left?
Yeah.
Unfortunately, the answer goes back to the idea of understanding that local soil, because in Bangladesh and that region, you have the fortune of the Himalayas right there that bring in, through the flooding, a lot of fertility, that bring in a lot of renovation. In some other areas, you don't have that. And when there's contamination that happens through war or through the PFAS or all these things, you can lose that forever, or at least in our human lifespan, it would be gone. So yeah, all these are really good questions, and none of them have a one answer, just because of the difficulties that each area has to confront.
Yep. No easy answers.
I think future agriculture has to be not simply about, unfortunately, not simply just about food security or food and nutrition security. So we believe in the kind of agriculture that we favour for soil security is what we call net zero, nature positive and nutrition balanced agriculture. So we would be looking to achieve those 3 goals at the same time. Obviously, if you do that, there's going to be trade-offs. So the yields might not be quite as high. There's questions about how much what the nutrient balance looks like. You don't want to produce too much greenhouse gases. So it's a balance, and it will change. So I think in the future we will have to have a more balanced food production system, and that will bring with it a more secure soil. When we talk about these global existential challenges, food security and water security and so on, and climate change, these things all work together. They kind of synergize. And soil security in itself offers solutions to these other existential challenges. And to some degree, these other existential challenges sometimes offer solutions to soil security. So we do need to think of them together at some level. But as soil scientists, which hopefully most of the audience is, we should be soil centric and always say that the soil is central to much of these problems, and we have to make that soil more secure into the future.
Great, thank you. So I'm going to draw our Q&A session to an end today. On behalf of the British Society of Soil Science, I'd like to express our thanks to Professor Alex McBratney, Dr. Sandra Evangelista, and Dr. Julio Pachon for coming along to present today. I'm conscious that it's quite late with you where you are, so we appreciate it. Thank you all also for attending. Yes.
Now, can I just say, and thanks, I just didn't get to say it earlier, thanks to the British Society of Soil Science for organising this. Apologise I wasn't able to talk to you earlier. I'm glad I managed to figure out how to use my iPhone. I really wanted to talk to you all this evening because I haven't talked to the British Society of Soil Science since 1986, so I just wanted to have another go because I probably won't get another one. Thank you very much.
Thanks, Alex, and we're really pleased that you were able to join us later on and answer the questions. Yeah, so thanks again, and we're sorry if it raised your stress levels earlier on in the webinar, but it all worked out in the end, and we had some great presentations and discussions, so thank you. And thank you for all our audience for attending and for all your questions. You'll find a quick feedback survey when you leave the webinar, and we hope you'll be able to take the time to complete it. The recording of the webinar will be available after the event on our website and our YouTube channel. And our next webinar is scheduled for the 30th of April. Topics still to be confirmed, but further details will be on the website in due course. So I hope to see you all at future events, and in the meantime, thank you all and goodbye.
Thank you.